Welcome to this short video on data masking with Fujitsu Enterprise Postgres version 14 on the OpenShift Container Platform. It's going to be one of a number of videos I'll do that cover the enterprise features of Fujitsu Enterprise Postgres. So data masking is one of the security features that allows you to manage visibility of data to different users in different situations utilizing policies. Those policies can be something that's quite simple, from saying this particular column, any value in there should be replaced with this fixed value, which could be configurable, right through to something that could be something like utilizing regular expressions to define which part of a very complex value, perhaps like a JSON-B document or an XML document, that could be stored within the database's column somewhere. So I'll start this session by quickly looking at the environment that I've set up, so you're aware of that, and then we'll look at what we need to do to enable data masking within Fujitsu Enterprise Postgres. Then I'll show you how to define the policies, and then we'll look at enabling and disabling those policies. Okay, let's get into it.
So we've got our Fujitsu Enterprise Postgres operator deployed to our Red Hat OpenShift cluster. We've used that operator as well to deploy an FEP or Fujitsu Enterprise Postgres cluster called FEP GWE1. This particular one's running a primary instance and a secondary instance, but we'll have a look at the YAML details for that a little bit later on when we look at how to configure it for data masking. To be able to test it, I've also created a very simple Node.js application that's in GitHub. So if we just go to GitHub very briefly, so we utilize an OpenShift feature called build feature that, so in our deployment it'll automatically go out and it'll download the source code from GitHub and build our container image and deploy it within the OpenShift environment. So it's called source to image, which is very good, but I just wanted to show you how we configure the connection to the database. So if we have a look at this JavaScript file here, I've defined it to pick up these connection details like the user we're connecting as, which database to connect to, which port in the host, from environment variables. If they're not defined, then it'll pick it up from a configuration file in here. And then what we can do is define those environment variables and push them into the container. Well, there's a number of ways of doing it, but I've just done it very simply in the deployment and specifying what those values are. Obviously we want to hide things like the password and things there's a number of ways of doing that, using secrets and so forth, but here we've just made it very simple so we can update this information. You'll see the host is 239.112, so that relates to the service associated with the pods. So pods, they could fairly transient. They could disappear and come back. So we don't, and the IP address would change. So we don't want to define that. So we use these services, and I will do another video that covers this in a bit more detail. But you can see the primary instance service here, 239.112. That's what we're connecting to, and this knows to connect to the appropriate pod running the primary database using these labels. So it's looking for one with a FEP role of master. So that's connected there. It's actually connected to that app. So that's the connectivity there. While we're in here, we'll have a look at the routes. So here's our airline booking application that's funded. So I'll click on here and we can see the app that's running in OpenShift. And what we'll do is use this bookings view that's getting information or data back from the database. That's actually using one of these queries, booking queries here, to get the various data. So there's the booking reference number, ticket number, passenger, and so forth, as it's displayed across here. So that's the application we'll use to test data masking. Okay, so let's have a look at what we need to do. So we'll have a look at our FEP cluster. Let's have a look at what we need to do to enable data masking in an FEP cluster. So this is the YAML file that defines what our deployment of Fujitsu Enterprise Postgres looks like in OpenShift. It's declarative, and what we can do in this YAML file is define what we want, and then it's reflected by Kubernetes. So we can make changes in here, and Kubernetes control area is responsible for making those changes. So you can see that it's actually been configured to create 2 instances of FEP. Sync mode off means it's running in asynchronous mode, the replication between the primary and the secondary. But what we want to have a look at is a little bit further down here in our custom PG parameters and this shared preload libraries. So this is something in our cluster configuration we need to make sure we specify the PGX data masking library. And that's really all we need to do here, and then we're in a position where, because the extension's all provided with the product, and all we need to do then is then go and create the extension. So when you do define this in the shared preload libraries, if you've got some other libraries defined there, please ensure it prior. You might have some issues if you define this after some of the other libraries. And that's it then. And when it's picked up, it's done. And the next thing we want to do is actually go through and create the extension for the airline database, which we want to utilize it for. So what we'll do is we'll go to our pod that's running our primary database, which is this one. And we can go into the terminal here, and we'll connect to our database. So host will be localhost from here, because we're actually on a shell in the pod that's running the primary, and ports 27500. We can define our users going to be Postgres, and the database we want to connect to is airline. Password, hope I typed this correctly, and here we are, we're connected to the database, and you can see we've got a number of tables and things in there that we can look at and get data from. So let's just select from our catalog table PG extension. We can see the only extensions installed at the moment is PL PGSQL for our server-side code. So what we want to do is we want to use data masking. We need to do a create extension, which is a standard way of installing extensions, and we want to install the PGX_data masking extension. Once we've done that, we can see it's been installed. Okay, rather than run and do things from here, what I might do is define, use dbeaver, but I'm running it locally. So to connect to this, we can only really connect to these database TCP ports from within the OpenShift environment without doing some other setup that I will cover in another video. But for now, what I will do is use an OpenShift container command line command called, I think it's called port forward. So I'm just grabbing a login command. So I'll copy that, and we can come to my Visual Studio, and we'll run up a terminal. So probably on a bash terminal here. Oops. So use a git bash one. And execute that. Oops, put it in twice. Bit quick with the mouse button. And now we're logged into OpenShift. So basically we have access to the same project COE GWE that we were before, and we are looking at with the GUI, but now we've got a command line interface to that, and so we can do various things in here. What we want to do is use a command called port forward. And then we specify what the cluster was, which was, let me just have a look, yeah, FEP GWE1 hyphen ST S-0, and I'm just going to forward port 27501. I normally do to 27500 that's being used within the cluster. Okay, so that's now running, and it's going to forward any requests from our local port 27501 to our database running in OpenShift. So we've got dbeaver as then use things in here. So we can now see in here our various tables in the database visually through here instead. So I'll just create a script, and we can do things in here, and then I can post the script, or they're a lot more visible. I'll just actually show you by selecting from the PG extension table again. And when we execute that, we can see we've got the results in here instead. So we call a function called pgx create confidential policy, and we specify where we want it to apply. So we're saying that the scheme is bookings, and the table that we want to apply this to is ticket flights. We're going to give the policy a name, and in the expression we're just saying 1 equals 1. So when this expression evaluates to true, then the masking policy is applied to that row. If it's not and it's false, then it doesn't apply it. So we can use this thing, so like if we can specify an expression where a user is above a certain level or not. If it's true, you might have visibility, or if he's below alert and visibility, you won't. Or we can even apply it to maybe a geographic region or a company that they work for, or something like that, or some other flag that we might have defined. So the column we want to apply it to is amount, and the function type, or the type of policy, is full. And I don't know if I mentioned before, but there's 3 different types of policies. It's full, which is a very simple one. Then there's a partial masking, and then there's a regular expression type masking. Actually, I'll just bring this down to the next line so you can actually see it a little bit clearer. Okay, so the first 3 columns specify what we're applying it to, and the last part is this is type of policy, the column we're applying in the expression. So I'll highlight this, and we'll execute it. Then if we go back to our application, if I refresh the screen and we do another select, these will change to 0. So that's our full masking. So now we'll have a look at partial masking. So what I'll do is I'll partially mask some of this passenger ID column here. So I'll pop back to, oops, deleted the results. I'll paste in some SQL. To create the partial policy. Again, this time I'll put it over some multiple lines here, so a little bit easier to see. So again, we call the pgx create confidential policy function. Actually, this one here I might put up because it's a 1 parameter. So again, we identify using the schema name and table name, and giving it a policy name. That's what we use as our unique identification for a policy. Here again, the expression, we're just making it always true, and the column name is passenger ID. But instead of function type full, we're specifying partial this time, and then we need to provide some additional parameters into this. So there's 4 specified here. So this is the what the values are. If there's a hyphen like in a credit card number, we can specify that there, and basically like the template that we want it to come out. This is our replacement character that we want, and we're specifying that the columns 1 to 8 need to be obscured. So we'll execute that. And then we'll go back and refresh the screen in our application, and we can see our columns 1 to 8 have been obscured, and it's just showing us the last 3 digits. So pretty straightforward. I'll just go back to our SQL. Now because we've defined the policies, well, actually first we can always look up and see what policies are defined by looking at a table called PGX confidential policies. Oops, didn't spell that very well. Execute that. Now we can see we've got our 2 policies that we've defined there. We can give them a description as well if we like. Makes it a little bit easier to manage if you do have lots of them. Okay, the other thing I mentioned is it's easy to enable and disable these policies. So I'll just paste it in again. Basically, we just call a different function, PGX enable confidential policy. We define the policy, and then enable equals false. So if I go through and I execute this, and then we go back to our application and refresh it, we'll see that the amount policy I disabled is now showing the values. So to enable that, we just set this to true. We'll execute again. Sorry, I should show you what I'm doing. So I've just in here, I've just gone in and I've changed the enable to true. And we'll execute it. And then if we go back to our application and refresh it, it zeroes it out again.